So இன்னைக்கு என்ன பார்க்க போறோம் அப்படினு பாத்தீங்கன்னா it's nothing but a summary part of first chapter. So in our 12th standard, so CBSE ல இருக்க first chapter என்ன அப்படினு பாத்தீங்கன்னா it is nothing but electric fields and charges. So our idea is nothing but electric fields and then charges. So in the chapter பத்தி பார்க்கிறதுக்கு முன்னாடி we will move on to a word or a term called electrostatics. So what is electrostatics? First of all, electrostatics. So electro, it doesn't mean, it means about charges. Okay. Statics is nothing but deals with rest. So rest variation is nothing but statics. Whenever a charge is at a state of rest, what are the phenomena or what are the behavior it will? So that variation is nothing but comes under electrostatics. Okay. Suppose the charge வந்து ரெஸ்ட்ல இருக்கும்போது assume பண்ணிக்கலாம். So what is the case அப்படின்னு பார்த்தீங்கன்னா whenever a charge particle, we will usually mention by a term called capital Q or small q. Okay. It is at rest. That is, it means velocity is said to be velocity is said to be 0. Velocity is equals to 0. So it will produce only electric field around the charge. So only electric field around the charge. For example, if it is a positive charge, it is nothing but a plus Q charge, there will be electric field diverging out in all the direction. When it is a negatively charged, electric field converge in all possible direction. So this is a simple variation of charge. So charge is nothing but a quantized factor. So we can measure the charge. How to measure the charge? Charges can be measured. So we will measure in a mathematical variation that is called as quantization of charge. How to calculate this charge? So this charge is nothing but calculated using Q is equals to N times E. So what is Q? Q is nothing but quantity of charge. N is nothing but number of particles. We will usually consider electrons. So number of electrons. What is E? It is nothing but a unit value of charge. In a scale we have a centimeter variation, right? Likewise there is a unit variation that is called as E. So E is equals to 1.6 into 10 to the power minus 19 cool. So it is a constant value. So we have a constant result that is called as E. Okay. So if there is a variation or if there is a 50 electrons in a particular system, it is nothing but all the 50 electrons will have the same amount of charge. So we will just simply multiply that number with the unit value. So we will get a net value like that. That is called as quantization of charge. Usually we will put a plus or minus sign in between them. What does it plus or means? Minus or means or nothing. Plus is nothing but a positive variation. Minus is nothing but a negative variation. Right? So in our simple logic, this is quantization of charge. Actually charges can be quantized. This is one factor. Charges are the first factor in is said to be quantized. Charges can be added. That is called as additivity. Also charges can be conserved. Conserved means if there is any process that takes place, total charge before the process is also equal to total charge after the process. For example, there is a system A and another system B. This system has some 50 electrons. This system also has 50 electrons. Okay. So by an external variation, by an external force or external disturbance, there is electron transfer takes place. Okay. So electron transfer takes place. For example, 10 electrons get transferred from A to B, which means the resultant will be 50 minus of 10. That is 40 electrons will be the remainder factor. Here 50 plus 10, which means there will be 60 electrons. So total charge before and after is said to be equal. What does it mean? This is Q of A and then this is said to be Q of B. So if I add the factors, QA plus QB is said to be 50 plus 50 is nothing but 100. Okay. Is nothing but 100. Similarly, after process, that is QA dash after the process, after the transfer, this is QB dash, this is also after the transfer. If I add these two factors, QA dash and QB dash is said to be 40 plus 60. Now it is also 100. So this is said to be conservation of conserved charge. Okay. Similarly, here itself we can explain the additivity also. Charges gets added, right? So this is explained here, additivity of charge, and this is said to be quantization of charges. Basic ideas. Then how to charge the system? charging can be done in three variations. One is said to be first process of charging is said to be friction process, friction, and second one is said to be by direct contact process, conduction. So conduction process, and then third process is said to be induction. Friction is nothing but rubbing the system. That is called as rubbing the system. Is called as friction. Conduction is nothing but a direct contact. If a charged body get or come closer to the uncharged body and kept in contact, there will be a transfer of charge from charged body to neutral body or uncharged body. This is a variation. Induction is a process. Charging takes place or charging is done by the means of without contact. This is known as induction process. So this is with the contact, and this is said to be without the contact. So this is a simple variation of charging. Okay. Then we will represent the system that is called as induced charge system. Once the system is charged, which is by the process of induction, is called as induced charge. So therefore, we will represent the variation that is Q is said to be inducing charge, and some Q dash we will consider another factor Q dash. This is called as induced charge. So we know that induced is nothing but came from induction process. So the initial charge will be greater than that of the final charge. That is, induced charge will be less than that of the inducing charge. Inducing means who initiate the process is known as inducing. What is the result is known as induced. That result will be less than that of the initial value. That is called as induction. Then we will move on to interaction. Interaction between the charges. The charges will interact. That interaction is nothing but responsible of force between two charges. So this is called as force. This force is nothing but Coulomb force. Coulomb's force. So that is given by the relation, a simple relation. F is equals to K Q1 Q2 by R square. What does it mean, sir, in talking about? It is nothing but product of the charges and inversely proportional to square distance between them. If you increase the distance, force will be less. If you increase the quantity of charge, force will be maximum, or decrease the distance, force will be maximum. That inverse variation. What is the value of K? K is said to be a constant of proportionality, which is equals to it is nothing but 1 by 4 pi epsilon. Mathematically, the value or numerical value is equals to, it is 9 into 10 to the power of 9 Newton meter square Coulomb minus 2. So this is the numerical value for this variation. Since force is a vector, so we can express this variation in a vector form. That is, F vector is said to be K Q1 Q2 divided by R square along the direction of line joining between those two forces. This is one force and this is another force. There will be a line joining, the direction will be the force direction. So we will give some variation. There is a Q1 charge and Q2 charge. For example, it is 2 1. What does it mean? 1 exerted force on 2, 1 acts on 2. So it is nothing but in order, so 1 2. So this is your variation. Similarly, in this variation, F 2 1 2 will be 2 exert a force on 1. It is nothing but K Q1 Q2 by R square along the direction of 2 1. Yeah. So from using this conclusion, what we will get this force and this force will be equal and opposite. So it obeys Newton's law's third law of motion. So that is F12 vector and F21 vector get added to a result particle vector. What does it mean? It means, actually what does it mean? It obeys Newton's third law, as well as it won't accelerate. That is, it explains the electrostatic behavior. Okay, it explains the electrostatic behavior. These two charges, it won't move each other by the attractive or repulsive force. It will stay in the variation, but the force will act between them. So this is the variation, one of the variation. Equal and opposite force, which means resultant force of the system, that is net force, is said to be 0. What does it mean? That is, the system will be in the state of rest. So this is the base idea of electrostatics. So this equation itself an important relation for superposition principle. Superposition principle. What does superposition principle means? If there are multiple charge systems, actually two charge itself a multiple charge system, because one charge it's a unit. single or unique charge. If one or more is said to be multiple charges. So we will mention in a special term that is two body system, but itself a multiple charge system. What will be the multiple charge system? If there are n charges, that is there is a q1 charge, q2 charge, and a q3 charge, q4 charge. Likewise, there are many charges are there, that is qn charge. All the charges will exert a force or will exert an attractive or repulsive force in whatever sense. Okay, force on the first charge, that is expressed or that is written in the form of 1 net. What does it mean? Net force acts on 1 is equals to summation of I is said to be 2 to n. What does it mean? 2 to 1 from second to n number of forces. So 2 to 1 f of 1i vector. So this is your variation. Okay. So this is further simplified into I equal to 2 to n. It is nothing but k q1i divided by q1 and qi. So divided by r square. R square means distance between those two factors along the direction of r1i cap. So it is also 1i square. So this is your f1 net. So this is your simple variation, or it is also one of the result of superposition principle. Okay. Next we will move on to the topic called field. So we just understood the factor called interaction. And interaction is further qualified by the term called field. Field is nothing but a force experienced by a positive charge. This is called as field. So that is nothing but force experienced. So electric field is defined as force experienced by a unit positive charge. So for this variation, we will consider a concept called test charge. What is test charge? Minimal quantity of variation is known as test charge. So this Q naught is named as test charge. Okay, this Q naught is named as test charge. So mathematically, force and field both are in the same direction. So both are same actually, but it qualifies. Interaction is qualified by the term called field. Okay, so interaction is further qualified by the term called field. So force, field, both are similar. Okay, that is force is nothing but interaction between two charges. Field is nothing but any one charge experience that interaction. That experience is called as field. Okay. Then we will move on to another topic called flux. This field further developed to another topic called flux. So from field we will move on to flux. So what is flux? Flux is nothing but number of field lines crossing a given region is known as flux. So this is said to be a region. There are electric field uniform or non-uniform, some variation. Okay, the uniform a uniform or non-uniform variation. So we will draw an area vector that is along this direction and field vector along this direction. So this is electric field and this is an area vector, usually represented by the term called n cap. So the angle between them is said to be theta. So flux is denoted or expressed by a symbol called phi of E. What does it mean? There are some two variations of flux is there. One is magnetic flux and another is said to be electric flux. So electric flux is usually represented by the symbol called phi of E. So that is nothing but electric field passing a given region is known as electric flux. So the dot product is expanded and express the theta, that is angle between the electric field and then area vector. So that is E A cos of angle between them. So this is a simple variation of electric flux. So this is for a discrete distribution. So there are some three variations of distributions are there. So charges are distributed in a line, that is linear charge distribution. It is nothing but lambda, that is charge distributed per unit length. If the distribution in an aerial form, it is called as charge distributed per unit area. It is expressed by the symbol called sigma. So Q by A. So if a charge expression or charge distribution in a three-dimensional form, it is called as volume charge distribution. That is charge per unit volume. So three types of distributions. So this is nothing but single point distribution, so it is called as discrete distribution. What happens to the continuous distribution? This is discrete is nothing but a point distribution. Okay, discrete is nothing but point distribution, point charge distribution. What will be the result for continuous charge distribution? Continuous charge distribution is nothing but same result. Phi of E is expressed as integral E ds. So usually vectors are represented as S or E, both are said to be similar. So E ds vector. So that is integral E ds. Cos of angle between them is said to be theta. So this is for this distribution is for continuous distribution. Continuous charge distribution. So even this distribution is considered for two surfaces. One is for open surface. So the integral is mainly represented like this. So this is for as open surface. What will be the result for closed surface? So phi of E is said to be integral E ds vector. So in that integration, we are integrating over a limited range or over a limited region. So we will use a term called closed integral. So this result can also be expressed as E ds cos of angle between them is said to be theta. So E ds cos theta. So this is one of the variation. Okay. So this is one of the variation. So this is for open surface, and this result is for closed surface. This closed surface result is also better explained by the term called, or by the law called Gauss law. So what is Gauss law? It's nothing but there is a closed region. So there are some charges within the region. If there is a flux responsible in that region is due to only the amount of charge enclosed. So this charge is named as QENC, that is enclosed result. So therefore electric flux is given by this relation as Q enclosed divided by epsilon naught. What is epsilon naught? This is nothing but permitting nature of the medium. Either it is nothing but R medium, so it is said to be epsilon naught. So these two equations are collectively written in this form. So these two equations are collectively written in this form. That is, phi of E is also equals to closed integral E ds cos theta, which is also equals to QENC divided by epsilon. So this is another form of Ohm's variation. Okay. Then we will move on to applications of Ohm's law. So what are the applications? We will study about single charge, that is a line charge distribution, as well as area charge distribution, and then volume charge distribution. So line charge distribution is nothing but charge distributed per unit area. So what will be the flux variation? It is nothing but electric field is nothing but that is lambda divided by this 2 pi epsilon naught r. So it is along the direction of r cap. So this is an electric field due to infinitely long straight wire carrying a charge. This is given by the relation. Okay. So next variation is area charge distribution. If the charge is distributed like this, what will be the result? E vector is said to be sigma divided by 2 epsilon along the n cap, that is the normal area vector direction. So this is given by this relation. Similarly, we will consider a spherical charge distribution, that is charge is spread throughout the region. Okay, throughout the area. We will measure electric field at 3 variations. One is R. R is said to be a point from the center. Okay. Also, the sphere has some radius. Okay. So if this R is greater than that of radius, which means a point is outside. So electric field outside the charged sphere is said to be K cube divided by distance between them is said to be R square. Similarly, if R is equal to, that is, if your distance is equal to radius, that is, your electric field is on, we are calculating on the surface, that is, E of S is said to be, it is K cube divided by, it is R square. So this is electric field on the surface of the variation. Similarly, if R is less than capital R, that is, it means your R is inside the sphere. If there is no charge enclosed within the sphere, because according to Gauss law, flux is defined as charge enclosed by the region to the top, or the charge is present in the region. So therefore, there is no charge enclosed, electric field is said to be 0 inside the sphere. So last topic is nothing but a concept called dipole. So two equal and opposite charges separated by a small distance, so it constitutes a dipole. So we will measure or we will represent a term called p vector. What is p? It is charge times dipole distance. What is the d vector is said to be? It is nothing but 2 times of that variation, that is dipole distance. Okay. So this is a simple variation of dipole moment. Though we have some 3-point system, 4-point system, but why we are interested in 2-point system? Even a 3-point system itself has some 2 points, another 2 points, here to here. So 2 points. So dipole is a base or unit like variation. So if there is a dipole, we are calculating electric field along the axis. That is called as electric field due to a dipole along the axial line. So it is nothing but, or it is calculated using the relation E axial is said to be axial, axial, okay, axial is said to be this 2k P divided by R cube. So this is your electric field due to an axial line. So if you are calculating electric field at the perpendicular variation, this is called as electric field due to equatorial line, that is K P R cube. This is usually expressed by the term called negative Kp by R cube. So what is the conclusion from this factor? So from these two results, we will conclude that electric field due to axial is equals to 2 times of electric field due to equatorial. So this is one of the important conclusion. So if you consider a point in any region other than the parallel line as well as perpendicular line, it is called as electric field general. What is electric field general? Is nothing but it is K P R cube root of 1 plus 3 cos square theta. So this is your electric field due to a general point.
What is the negative symbol?
It is nothing but for this alignment, electric field and dipole moment will be opposite in direction. That's why there will be negative symbol. Okay. So this is a general variation. Okay. So these are all the topics or subtopics is given in your first chapter. So basics about electric field, electrostatics, then electric field. First we will discuss about what is charge. There we will continue as some properties, 3 properties, then process, from then interaction. That interaction is qualified by the term called field. That field is further explained or further developed. Further logical model is called as flux. From that flux, we will see an application, or we will see Gauss law. What is Gauss law? Then from that we will see some applications. From that application, this is another topic actually. That is electric dipole. Dipole. Then what is dipole moment along the axial, equatorial, and then it is said to be gentle. Then we will conclude some connection factors, and then the important result is the superposition principle. So one of the important result we will get. Okay. So usually we will take a 2-particle system, and we will take a 3-particle system, 4-particle system, and we will do some calculations. So these are the basic ideas about chapter 1. So now any doubt? So, okay, we will develop second chapter.